Hello everyone, in this tutorial we will discuss about Dijkstra's algorithm, and using Dijkstra's algorithm we will calculate the shortest path. This is the graph given. There are 6 vertices and 7 edges. The cost between A and B is 4, the cost between B and C is 1, the cost between A and C is 2, the cost between C and D is 5, the cost between B and D is 5, and so on. The starting vertex is A and the ending vertex, that is the target vertex, is Z. So let's start the Dijkstra's algorithm. For this, the Dijkstra's algorithm, we will make all the vertices level as infinity. Only the starting vertex, that is A, should be level as 0. Now for Dijkstra's algorithm, we take the minimum cost. There is a minimum one among all these. Among all these, the minimum is A, that is 0. So we will start calculating from A. Now we will check for the neighbor vertices between A. On A, the neighbor vertices on A are B and C. So now we'll check for the shortest one. Now we'll update the cost. Now the cost of A is 0 and the cost of C is infinity, and the cost between A and C is 2. So now we will calculate the minimum one, that is minimum of infinity and 0 plus 2. That is the cost of this one A, that is 0, and the cost between A and C, that is 2 plus 2, and the cost of C is infinity. Okay, that is we will take the minimum one. So here the minimum is between infinity and 0 plus 2 is 2. So we will update C with 2. Similarly, the cost between A and 4 is A and B is 4, and the cost of A is 0 and the cost of B is infinity. So 0 plus 4 is minimum than infinity. So we will update with 4. Now we will check for the minimum one. The minimum is minimum between A and C. The cost is 2. The cost between A and B is 4. So 2 is minimum. We will choose this path. Now we will mark this. Now we will mark this C also. Now we will check for C. The neighbor nodes of C, neighbor vertices of C are B, D and E. So now the cost of C is 2 and between C and E is 10, and the cost of E is infinity. Now we'll check for same thing, that is minimum of infinity and 10 plus 2. Which one is minimum? 10 plus 2 is minimum than infinity. So we will update infinity with 12. Similarly, the cost between C and B is 1, the cost of C is 2 and the cost of B is 3. So 2 plus 1, that is 2 plus 1 is 3, is minimum than 4. So we will update 4 with 3. And this C and D, the cost of C is 2, the cost of C and D is 10 and cost of D is infinity. So 2 plus 8 is 10, is minimum than infinity. So we'll update infinity with 10. So which one is minimum among its? 3 is minimum. So our next path is like this. Now we'll mark this B. So between the neighbor vertices of B is only D. So we'll update D. Let's check for D. the cost of B is 3, the cost between B and D is 5, and the cost of D is 10. So the minimum of 10 and 3 plus 5. Between 10 and 3 plus 5 is 3 plus 5 8. 8 is the minimum, so we'll update 8 with 10 with 8. So our next path is like this, and we'll mark D. Now the neighbor nodes of neighbor vertices of D are E and Z. So now we will check for E and Z. The cost of D is 8, and the cost between D and Z is 6, and this one, the cost of Z is infinity. So 8 plus 6 14 is minimum, then infinity. So we will update infinity with 14. And the cost of D is 8, and the cost between D and E is 2, and the cost of E is 12. So now 8 plus 2 is 10, and 10 is minimum than 12, so we'll update 12 with 10. The same formula apply. So between 14 and 10, 10 is the minimum, so we'll take this path and we'll mark E. Now only the neighbor vertex of E is Z, so only Z is left. With the cost of E is 10 and the cost of Z is 14. The cost between E and Z is 3. This 10 plus 3 is 13. 13 is minimum than 14, so we'll update 14 with 13. So this is our final answer, 13, and the shortest path is this A, then C to B, then B to D, then D to E, then E to Z. So it's A, sorry for my handwriting, C, B, D, E and Z. Okay, so this is it. This is the algorithm. I hope you would have understood a little bit. Thank you for watching.